Okay, so I wanted to record this just to break down how we solve these different problems. So the first problem I want to look at is single step multiplication. And when we look at this, we want to make sure that we read it correctly. So Tommy has 24 packs, baseball cards. Each pack has 14 of them in there. How many total cards does Tommy have? So when we solve this, we use a window pane method. So I'm going to do an upside down T, which is our window pane. In this one, we have our question, right? So how many total cards? And then we have our picture. So it's looking for a total. So that is something that we do not know, right? That's our total. But we do know that we have 24 packages of cards. So instead of drawing 24 boxes, I'm going to go 1, 2, skip a few, all the way to 24. Inside of each box or package is 14 cards. So we know that if we have two parts and we're missing a total, that it's going to be multiplication. The way that I have taught multiplication is that we're going to do the box method. So box method is where we decompose both factors because what we're doing is 24 times 14. So we're decomposing both factors into, so I've got 20 plus 4, and I have 10 plus 4. Right? These still equal 24 plus 14. The way that we do box method is we bring down, we call these skydivers, we bring these down, all the way down. Then we're going to multiply. And we call these crosswalkers. They're going to go all the way across. These are going to go all the way across. There we go. Okay, so we have something called pushy zeros. That means that the zeros can go down and they wait for us. So 1 times 2 is 2. 4 times 1 is 4. 2 times 4 is 8. And 4 times 4 is 16. Now these are called partial products. So what we're able to do is we're able to add all of our partial products together to come up with our answer. 6, 4 plus 8 is 12, plus 1 is 13. And we have 336 baseball cards. All right. So let's say we want to keep going. So I'm now doing this with multiplication multi-step. So the way we work this through, we still read it. He has 24 packs of baseball cards and each pack has 14 cards in them. Stop. When we have multi-step, the way that we do this is we break it down sentence by sentence. So 24 packs of cards. 1, 2, skip a few, all the way to 24. Each pack has 14. Now, do we know how many total cards there are? Not according to this, we don't know, but could we find it? Yes. So that is what we call our hidden question, a question that isn't asked by the problem, but we have to know the answer in order to move forward. So again, we're looking for total baseball cards. And we do our box method where we decompose the factors. And the only reason why I'm doing this shorthand is because we've solved it in the previous problem. And we figured out that when we added it, we had 12, 13, 336 baseball cards. We're not done. We keep going. He gives 12 cards to his sister. So we know we have a total of 336 cards, and I'm going to be giving 12 of them away. We're now looking for the number of cards he has. Number of cards now, right? So this picture tells me I take my 336 and I take away, because I gave them away, 12. So I have 324 cards now. That is my final answer. Okay, so we know that multiplication happens when we have two pieces, but we don't know our total. Now we're going to look at what happens when we have our total, but we don't have the pieces. So it says there are 248 cars on a cargo boat. These cars are being delivered to 4 different dealerships. How many cars are going to each dealership? Okay, again, we're going to do our window pane setup. So our question goes over here. How many cars to each, right? So I have a total of 248 cards, and I'm separating them into 4 different dealerships. Now, division happens when you have a total and you're trying to find a piece. We want to know how many are going to each dealership. So what we're going to do is we call this the big 7. So we're going to put our total as our dividend, and we're going to put the number of pieces as our divisor. The way that this works is we do a T-chart and we say, okay, times 4, and we work with friendly numbers. So we have different levels. That's how many digits we have. So I'm going to do it by 2s, 5s, and 10s. Those are the nicest numbers I've got. 20, 50, 100, 200, 500, 1000. These are friendly numbers. So 2 times 4 is 8, 5 times 4 is 20, 10 times 4 is 40. I did not go over my dividend, so I get to keep going. And the good news about this is I just have to add a 0. So 400 is too much. I can't do that, so I don't have to fill in the rest of this. So I can do a group of 50, and that will eliminate 200 of this. Right? I can do that good. I can also do a group of 10, which will eliminate 40 of this, leaving me with just 8. And I can do a group of 2, which would eliminate 8 of it, and I'm done. And so what I have to do now is I have to add my partial quotient. So I'm just going to add these. 50 plus 10 plus 2 is 62. So I have 62 cars going to each dealership. Okay, I'm going to step it up. We're going to go to multi-step with division. Again, there are 248 cars. These cars are being delivered to 4 different dealerships. Okay, I'm going to stop. I know I have a total, and I'm breaking it into pieces. And I want to know how many go to each dealership, because that's something I don't know. It didn't ask me for that. So that's called my hidden question, HQ, hidden question. So again, I would divide. It's 248 is my dividend. 4 is my divisor. I make my friendly number T-chart. You can do 1, 2, 5. And then you have 10, 20, 50. And you can have 100, 200, 500. Well, 400 is too much, so I don't need to keep going. Okay, so I can make a group of 50, take a group of 50 out of there, which would eliminate 200 of this. And I have 48. Then I can have a group of 10. That would eliminate 40. And then I can eliminate a group of 2, which would eliminate 8 of it. Add that together, I have 62 cars. Okay, I'm not done. The next part says, one dealership noticed that 34 cars were scratched and could not be sold. How many cars did they have to sell? So how much to sell? Well, I have 62 cars on the lot, and we know that 34 of them could not be sold. So we want to know what's left over, what could be. So we're going to take 62 and we're going to take away 34 that can't be sold. And so this is going to be 28 cars could be sold. So, okay, remember, if we are looking at multiplication, we are going to have the parts, but not the total. So we'll have question mark for the total, but we'll have the different parts. So this would be 4 groups of 7. 4 groups of 7 is equal to some number. That's what this picture is saying. For division, that means we have a total. And then we have a part. So if we have a total and a part and we're looking for a part, that means that we are going to divide using our big 7 method. So that's 264 divided by 4. Okay. So when we do division, we have our big 7. That means our dividend, our large number, goes on the inside. Our divisors on the outside, and we make our friendly number T-chart, which is 1, 2, 5, 10, 20, 50, 100, 200, 500. As we fill this in, our numbers can stay the same, except we're adding a 0 each level. Once I get to something that's is larger than the dividend, we get to stop. And we get to pull out groups. So when I find a group that I can pull out of, it's here. I'm going to subtract. I'm going to pull out another group. A little bit longer, but it will work. And then we add up all the rest. So that's 50 plus 10 is 60, plus 5 is 65, plus 1 is 66. I hope this helps.